So y, or f of x, doesn't really matter, right, equals the sine of x, where x represents your input. This is 4-5. Graphing sine and cosine. Okay. With that being said, f of x equals sine of x. X represents the input. Once again, this is another reason why we don't get into degrees, because we are actually labeling our graph, where this is the x's, this is the y's, right? Inputs, outputs. Do we really want to put 0 degrees and so forth? No, we don't. We want it in terms of radians. Okay? So I'm going to start with 0, okay? Because that's our first angle on the unit circle. What is the sine of 0?
0.
It's 0, right? Because remember, on the point itself, right, the point of the angle, it is the y value, correct? Okay. So, with that being said, at 0, we get 0. We're going to put, well, still even at a certain height, water doesn't help. Okay. So we plug 0 in. This is where it's at. What's the next good value to pick? Pi 6 is a great place to start. I'm going to hurry mark this as pi half just so I can kind of get an idea, because it's cut into thirds basically, right? So here's the further. That's pi 6. That's about halfway. That's pi 4. So this is about another third. So that would be pi third. Okay. As Nicole just said, let's go ahead and start with pi 6. So what is the sine of pi 6? It is a half, isn't it? Okay, so if this guy right here is 1, a half is roughly about right there. Then we go to pi 4ths. Root 2 over 2, which is like 0.707. So roughly about that. Hi.
Mr. Roberts, I have a question for you.
I have it. Okay, so back on it. So now we're going to go to pi thirds. When we look at pi thirds, the sine of pi thirds is root 3 over 2, correct? Which is, I think, 0.80, 0.85 or something like that. It's pretty high. And then we go to pi halves. What's the sine of pi halves? 1. Yay. Are we ever going to get higher than 1 on our unit circle? No. And that should make sense because, one second, that should make sense for the fact of the matter, on a triangle, the hypotenuse is always the largest side, correct? So therefore, the opposite has to be smaller than the hypotenuse, correct? In a right triangle. So therefore, that's why it will never get larger than 1 for the sine value. James, you answered my question. Okay? Everybody there with me? Okay. So, really, guys, what does that look like? It looks like a damn circle.
Oh.
It's the first quadrant of the circle. If you think about it, doesn't that make sense?
Oh, yeah.
Why didn't you put like pi 6 and pi 4s and pi 3s and pi halves? I don't want to do degrees.
Because that's your x value. That's what you're plugging in for x. You're taking the sine of that. So that's another reason why we don't do degrees.
Sine of pi over x is going to be...
Pi over x. What do you mean by that?
Sine of pi over 6
would be...
is 1/2.
Exactly. That's why I plugged in pi 6. Sine of pi 6 is a half. Okay, now, ladies and gentlemen, I don't expect you to do all 16 angles. Kind of get the idea. What's going to happen here? You get the idea this is the circle unwound, right? So go to pi now. What is the sine of pi? 0. Kind of get the curve, because once again, this is the circle. And notice that's the y values. If you look at your unit circle, you're using the y values for the first 2 quadrants. Okay? With that being said, now I'm going to go to 3 pi halves. Notice, what's your y values in quadrant 3? So therefore, I'm going to go down, aren't I? Because your y values are negative. Here's negative 1, and the sine of 3 pi halves is negative 1. Okay? And then where do we go back up to? 2 pi. And that's at 0. Okay. That is a basic graph of sine. Now, is that all that sine graphs? So like when I go ahead and do this, I'm going to plug it in my calculator. This is what sine is going to look like, right? Let's see. Go to your calculator for me. Mine's thinking. First off, I'm going to go to mode, make sure I'm in radian. Y equals, I'm just going to do the sine of x. That'd be all I did is go y equals and plugged in sine of x. That's all I did. Okay, now, notice, ladies and gentlemen, what I did was personally just 0 to 2 pi. Notice 1, 2, 3, 4, 5, 6, and a little bit. 2 pi, right? Does that make sense to everybody? But notice, that's not what this graph does, is just that. It should make sense that it continues to go on. Why? I can keep going around the circle, right? Then I go to, instead of pi 6, I go to, 13 pi 6, right? And that gives you a half, right? Does that make sense? Then I go to 5 pi halves, which gives me 1. Then I go to 3 pi, which gives me 0. 7 pi halves gives me negative 1. 8 pi. Not 8 pi, 4 pi. Yes.
So, so for cosine, so this is sine.
This is sine.
Like when this, you know,
We're going to do cosine in just a second.
Yeah, that's fantastic.
It does not. It does this, it almost looks exactly like this. It's shifted. So here's what this is. Now, we're going to talk about a few words, okay? Now, I'm not going to try to offend anyone, but I'm going to use as something that hopefully you guys all signed waivers for. Okay, in just a second. So first off, amplitude. What is an amplitude? How many of you guys taking chemistry/physics? I think it's more in physics than chemistry, I think, though. Amplitude. What is the definition of amplitude you learned in physics? The height? Close. The wavelengths, right? Okay, something in there. It's actually the height or the distance from the midline. My midline is here, meaning notice my highest point is 1, my lowest point is negative 1. So you find your midline, which is at 0, right? That's the halfway point. So therefore, our amplitude is a distance of 1. Okay? What if I, instead of went up, went down? What's my amplitude still? Still 1 because it's a distance, correct? And so therefore it can't be negative. Even though it's flipped, right? It's still 1. Is everybody there? Is anybody else remembering a word that you were taught in physics when it comes to waves and things like that? Magnitude, we're not necessarily going to do magnitude. Frequency. Okay? Frequency is our B value, which I haven't gave you our generic one yet. But notice it's also telling you how many times you do your graph within a normal period. Okay? You guys ever heard of period? Huh? 1 revolution. Basically, my definition of a period is a complete cycle is going to its extreme high, to its extreme low, back to its original starting point. Okay, because look at sine here. Give me 1 second on it. Where you just picking up your hat. So notice sine starts at 0. I get back to 0, but is that a cycle? Because I went to my extreme high, but I haven't done extreme low. So notice I get back to 2 pi. That is the distance of sine's period is 2 pi. Okay. Now, I'm not trying to be all weird here, but I'm going to say it anyway because this is a way to remember. One of my teachers told me this and it works. Okay. Ladies, we all don't. I don't. You have a cycle. What do we call it? Oh my God. I'm going there. Helps you remember. The distance of one cycle is a period. Okay? And I'm sorry I went there, but it helps remember. I'm sorry if that offended anybody, but that is your period. And notice the distance of our period on sine is 2 pi. That is the distance of one complete cycle. Okay? Hopefully I didn't offend anyone. If I did, come talk to me later. I apologize wholeheartedly, which I'm doing right now. Okay. Anybody have a question?
So period, like when it gets back to
The original starting point. The distance of one complete cycle.
So in this case it would be pi or
No, 2 pi. Because it's the distance of one complete cycle. At pi, it's only half of our cycle, right? Everybody with me? Okay. We all good? Okay. Now, we obviously haven't adjusted this. This was what we consider our parent function for sine, correct? Hopefully, once again, you do understand that it does come like this, right? We all get the idea? We can handle that? Okay. There are times I might ask you to do 1 cycle. There are times I might ask you to do 2 cycles. So what would be the length if I'm asking you to do sines 2 cycles? Where would you start at? I'd go to 0 and end at 4 pi, or I'd start at negative 2 pi and end at 2 pi. Does that make sense? Okay. With that being said, let's do cosine now.
isn't that basically go the opposite direction?
Nope. You guys quit thinking on your own. Here we go. So we still start at 0. Cosine of 0, once again, when you look at the coordinate point, is the x value at the coordinate point, correct? Okay, understand you will not have your calculator on this part of the test. So don't rely upon it. Okay? So, when we start at 0, what's the cosine of 0? 1, right? Then, I'm going to skip the pi sixth and so forth because I think you're going to get the idea. We just go to the pi halves and everything, right? So I'm going to go to pi halves. What do we get? Look at it.
1, 0.
Whoa, hee-ha-hoo.
0.
It's 0. Then where do we go? Pi, which is negative 1.
It's the same thing except when you show
Well, we already gave you that idea anyway, earlier. 3 pi halves is 0, and 2 pi is 1. Now, don't make it a V, it is the circle. So kind of like, wow, Karate Kid style, right? Up on top doing the crane kick. What are you talking about?
That's from the movie.
The one with Little Will Smith or non-Little Will Smith?
The 80s one with white kid
So
and black
long.
kid. White kid.
I wasn't going there, but
The one with the white kid.
okay, so let's talk about it. What's its amplitude? And that makes sense again, because how far does your x value go? 1. What's the lowest it goes? Negative 1, because once again, same thing with sine, the hypotenuse will always be larger, won't it?
Yeah.
Make sense? Okay. What is our period? Still 2 pi. That's how long it takes to get around the circle, doesn't it? Sir?
So if we're always just using generic cosine or sine of x, it's always going to be 2 pi as the period?
Yes, sir. Okay. Now, with that being said, oh shit, what did I just want to talk about? Thanks a lot, Dave. Frequency. Frequency is just how many times you can do your graph within 2 pi. That's what frequency is.
It's just
I know.
Cosine equals sine x plus I half,
Oh, that's exactly what I'm going with. Okay. So, remember, cosine is the same thing as, or you could say sine of x is the same thing as cosine of x minus pi halves. You guys remember me showing you that theorem?
and sine is
So therefore, if you think about it, excuse me, this is a plus pi halves. I apologize.
and it's the same thing.
Okay, because if you think of our sine graph, I'm going to do that in blue really quick. I understand what you're saying. Just trying to go at it real quick. Okay, so there's the sine graph. Can you see that we took the sine graph and shifted it to the left, pi halves?
Yeah.
It's the same exact graph, except there is a transformation.
So,
Okay?
why is it plus pi half?
Because remember on the transformations, I was off on it, to be honest. Remember on the transformations, anything on the inside is opposite what you see, so we go to the left. So this point that was at pi halves got shifted over to 0.
Actually, when it was minus because of the line.
No, but it's opposite.
You don't want it to be minus because here's your sine graph. Then you take it here, that doesn't make sense. So you want to have this low point go to that low point, that high point go to that high point. That's it.
But you add that side.
That's true. Damn the man. I knew I had it right, then I looked at it. Why you gotta bother me?
Sorry.
'Cause you're right.
I get confused.
You're good. He was right, I was wrong. Let me talk about it one more time.
Well, I just.
Hold on, here we go.
Oh my goodness.
I thought I had it right. But then I was thinking I shifted the sine graph. That's what I just did. So cosine is the exact same thing as what I just did there, is sine of theta plus, or x, plus pi halves. That's what I was talking about originally. But this, if we take our cosine graph and shift it to the right pi half, it's now the sine graph. Thank you. Okay, either way, does everybody understand what the sine graph looks like, the cosine graph looks like?
Yeah.
Do you understand they all have the same amplitude, they both have the same period, right? Now let's talk about some differences. Where does sine start at? It starts on the midline, right? And what does cosine start with? The amplitude. That's how I like to say it, okay? If you'll also notice, I kind of have a pattern here. This is how I remember to do it quickly. Notice you go high, midpoint, low, midpoint, high for cosine. For sine, you go midpoint, high, midpoint, low, midpoint. It's like a little pattern. Everybody see it? Everybody good? You guys ready to graph?
Yeah.
You want hard, or you want me to ease you into it?
You just hit us with it.
Hard. Okay, just hit it.
Just
No,
slap us.
just be hard.
Just a bad slap on the face.
Let's slap you in the face.
Oh,
No,
I already felt that.
please.
How did you already slap in the face? I don't know. I just felt it.
No, it felt like you were slapping him in the face. Hey, that. I don't think anybody's slapping me.
I love you, thank you.
Oh.
That's the hardest you're gonna see today. Well, maybe not the hardest, but pretty much up there. It has everything in there that you could do to a graph. We have stretching, we have shifting, right and left, and compressing horizontally. Okay, we have everything you can do. So, let me show you the process that I like to go with. First off, this is y equals a sine or cosine, depending on which function you're in, right? Of bx plus c plus d. That's your basic generic form. Sometimes you might not have a, sometimes you might, well, you're always going to have an a. What's always a if it's not there? 1. Right? B is always going to be there. If you don't see it, though, it's always going to be 1. C, is it always going to be there?
No.
No.
This last round will be.
D is in David. Hey, by the way, you got to take your test today or you lose your points. Just make sure. Anybody else missing on test day? Can you think of only? I'm only thinking of you. All right, you guys ready? A, what do you guys think A stands for? It is your amplitude. What do you guys think B stands for? It is your frequency. C is called your horizontal shift. And D is your vertical shift, which we also call our midline. Okay? I am going to show you the process that I go through to draw a graph when it's in this case. Okay? It's a 4-step process. Okay? Once again, I'm a chart guy in a way almost, but I'm not technically doing it by a chart, but semi I am. Does that make sense to everybody? Everybody with me? Okay, so here we go. So, the first thing I do, obviously have your graph, I look at my actually I look at my midline. Where's my midline?
0.
Nope. It's at 1. We got shifted up 1, huh? Normally it was at 0, but then it shifted up 1. So therefore this guy right here is 1. And what I do for my midline, I like to do a dotted line to represent my midline. Go ahead, Austin.
You don't like to do charts on these.
I don't do charts. I just kind of have the idea and I run with it. Then, after I do my midline, I use my amplitude. So, remember, amplitude. What was our definition of amplitude? Distance away from the midline. What is our distance away from the midline?
Three.
3. Amplitude can't be negative. Right?
Yeah.
Now, is it negative? I'll show you what that does in a second. So we go 1, 2, 3, so the highest it's ever going to be is 4. 1, 2, 3, the lowest it's ever going to be is -2. Anybody have a question on how I just went about that process? Very basic, very simple, correct? Now, the midline is D. So I just shifted it up 1. Does that make sense, Austin? Okay, if you recall when we did transformations at the beginning of the year, remember doing transformations? We have this 2. Remember, we got to pull him out, don't we? So this is parenthesis 2 parenthesis x minus pi halves. You guys remember doing that? Okay. So what I like to do, I'm going to come down here because I'm running out of room. It was 2 parenthesis x minus pi half is what we're going to do, isn't it? Correct? All right. What's the original values that I was using for my sine graph? What's the 5 values I was using? 0, pi half, pi, 3 pi halves, and 2 pi. Okay, those are the main, it's kind of like my Fab 5 of graphing a quadratic, not quadratic, a trig function. Okay, so what do we do first, the shift or the timesing? We do the timesing. So, remember, this was technically inside our function, wasn't it? And what do we do anytime we're on the inside of our function? We do opposite of what we see, correct? So I'm going to go ahead and times these by what? A half. So I get 0, pi fourths, pi halves, 3 pi fourths, and pi.
So now you are doing the chart.
Kind of. Like I said, I kind of am, but I'm kind of not. Because I'm not putting the y values with them, I'm just using my x values, correct? Does that make sense, Austin? Bro?
So what did we just do?
All I did is I took the x values, and because of the timesing by 2, remember anything on the inside, you're going to do opposite what we see. So we see timesing by 2. So we're going to divide by 2, or, we don't like dividing really, so timesing by its reciprocal. Are you okay there? What did that just affect? That was our frequency. It helps us with our frequency, but what did that just affect? It did shrink it. We're still not getting to what my answer is. What did that just affect? The period. Notice, beforehand, it used to take me 0 to 2 pi to complete a whole cycle. Now, it's taking me how much? 0 to pi. So therefore, that b value affects your period. I'm going to show you with a little thing in just a minute if they ever ask you what's your period if they have a graph. I'll show you how to do that. Okay? All right. Then, are we done? We need to now do what? Shift everything to the right pi halves. Everybody with me on that? So therefore, instead of 0, I start at pi halves. Instead of being at pi fourths, I add a half to that. That's 3 pi fourths. Pi. 5 pi fourths. If you see the pattern, notice that's 2 pi halves. Excuse me. Let me think here. 2 pi fourths, 3 pi fourths, 4 pi fourths, 5 pi fourths. So this one's going to be 6 pi fourths, which is 3 pi halves, right?
So you're just adding a half.
Just adding a half. Pi halves, technically, right? To each of those. Is everybody with me there? Was that hard? Pretty simple. These are now my new x values. Okay? So I go up to the top to my graph. Does everybody have those written down that we can then pull them up?
No.
I will wait.
I can't.
Ready?
Which one period?
Pi halves. 1 second, so I'm going to say this and I'll answer your question if that's okay. Pi halves, 3 pi fourths, pi, 5 pi fourths, and 3 pi halves. Those are what they say. You okay with me now, Austin? By adding pi halves to 0, pi fourths, pi halves, 3 pi fourths, and pi. Austin, are you pissed? That's how you slam that hat down. I love the smell of my room. Smells delicious. No, I'm just, look at him. I'm freaking crying out loud here.
I thought you were giving them the sound again. I got weird to turn that.
Okay. Is everybody with me? Down. Did I get you? Okay. Does everybody have these points? What's still the period between pi halves to 3 pi halves? Still pi. I didn't change my period, I just shifted it, right? Okay, so we come up here. So here's roughly pi halves. There's pi. There's 3 pi halves. Notice, and then I just kind of went from this to say that 3 pi fourths and 5 pi fourths. Now, most of the time, I only really require the 1 period, but today we're going to shift it to keep going. Does that make sense? Yes, no? So therefore, I'm also going to say 2 pi. Go erase it. Okay, so 2 pi. Then we have 5 pi halves. And then let's go from there. So then we do increments again. This would be 7 pi fourths. And this guy right here will be 9 pi fourths. All right, you guys ready? Yes, no? This is 5 pi halves. Anybody have a question? What I just did there? Okay, now I look at 7 pi fourths, 2 pi, 9 pi fourths, 5 pi halves. Okay, so noticing here we go. You guys ready how to graph now? We did all the hard part. Graphing is the easy part. Okay, you start here at pi halves. Does sine start on the midline or its amplitude? Midline. Now, we brought up earlier amplitude. What's the amplitude? 3. 3 is our amplitude. But because it's negative, we have a graph that starts out with a hump, right? Then comes down. But what does a negative ever do? Like even if I had a y squared, it flips me down. So instead of going up, I'm going to go down. So I'm going to go midline, low, then where?
Where do you do your low at?
At -2.
No.
So I just go along, just do the tick marks. It's the same pattern. Does that make sense, Austin, or no?
Yeah.
So remember, if you remember what sine normally was, it was midline high, midline low, midline.
Yeah.
Okay? So this time I'm going to go midline low, midline high, midline. I mean,
+1 doing low.
that shifted us up. Instead of our midline being a 0, we're now at 1. Okay, so we went midline, low, midline, high, midline. There's our sine graph. Now it's off because my scale's not correct.
Is your midline high 3 above your bottom line?
Say again?
Is your midline
My high point is my using my amplitude, which is 3 points higher than my midline. Because that's what the definition of amplitude is. Once again, using your midline a distance away from your midline, correct? There is one cycle. And what is that distance? Still pi, huh? Okay? Now, I'm going to keep going on. I should have been here, I apologize. My graphs aren't always the prettiest. Now I'm here, where do you guys think I go?
So that
Low, then midline. I'm coming back off.
No, you did it. I got it.
Notice I just did 2 complete cycles. Okay, if it didn't get shifted to the right pi halves, how many cycles happen between 0 to 2 pi? 2. Look at your b value. 2. That tells you how many times you're going to complete a cycle within 2 pi. So if there's 8 cycles by the end of 2 pi, what's your frequency? 8. Does that make sense? Okay, so notice, if they ever just give you an equation, ask you for your period, basically, how did we get our period? How did we shrink it from 2 pi to pi?
With the frequency.
Using the frequency. And notice, what did we do there? We took 2 pi and did what to it? Times it by what? 1/2, or 1 divided by our b value. Or 2 pi over b is our period. Always. 2 pi divided by b will always be your period for at least sine and cosine. Does that answer your question? Okay. I noticed that came from that. So, I mean, like for example, I'm just going to draw something here. Just bear with me. Oops, that's horrible. Let's not do that. Okay, here's this. What would be my frequency? 3. B3. Because notice, I know they're not exactly even, but you're bearing with me here, right? There's 1 cycle, right? Everybody see that? 2 cycles. 3 cycles by 2 pi. That would be, if I wanted to write the equation, that would tell you your b value. Does everybody see that? So our period would be 2 pi thirds, huh? Yes, sir.
So going back to the last one, and maybe I missed it on that, but on 2 pi, it's ending at the midpoint, right?
Uh-huh.
Okay, so that's going to give you, your 1 cycle is going to be at 3 pi half, right? Well, but it's
Well,
not
we actually
because
start from here to here.
if we start it back at the 0, where x equals 0, that would be at 4, right? 0, 4 would be that first point? Or
No.
do we just...
It'd be at 0, 1. Because we shift him back over here.
So how's...
So we shift him, this 2 pi, back over to 3 pi half over here.
Yeah, right. I don't see the second cycle on this.
Okay. No problem. Let me go ahead down first.
So then would pi half be at 4?
No.
No.
5 pi fourths is at 4. My graph didn't get high enough. I apologize. That probably makes it look better, doesn't it?
But
It should be the 5 pi fourths, because notice, think about it originally. Just look at what we're here originally. If you don't consider the shift, this is kind of like 0 pi halves. Oh shit! I lost it right there. No. That would be pi half. No, pi. 3 pi halves and then 2 pi, right? But you gotta understand we compressed as well as shifted.
And you can grab a high force.
Exactly, there's 2 shifts to get over to pi. Okay, let's just do one more. I think one more might help you. Okay? If I messed up after that, then we'll talk. It's really a pretty simple process. But the second thing that you got to do is just keep adding pi fourths, because each increment is pi fourths. Do you see that? Because notice we got 2 pi fourths, 3 pi fourths, 4 pi fourths, 5 pi fourths, 6 pi fourths, 7 pi fourths, 8 pi fourths, 9 pi fourths, 10 pi fourths. You're just doing that. Each section basically has 5 points. You have your starting point, the high, the midline, the low, starting point again. Does that make sense?
Yeah.
So here, starting at this point right here, going to here is another cycle.
Oh, so you do the cycle clear to the end, not just to the 2 pi?
Nope, you go all the way to complete 2 cycles.
Because of the shift.
Mhm.
Got it.
Even on the other one, even if I want to do 2 cycles, technically if I just had regular sine, I see what your question is now. Even if I had regular sine, I'd go to 4 pi if I wanted to do 2 cycles.
Yeah.
Okay? You just keep going until you finish. But notice, if we didn't have this shift, right here, this pi halves was basically over here, and we'd finish 2 of them by pi.
So why do we start with it? Well, let's just do another one and then we'll see what question.
See what question you might have. Okay, you guys want another hard one, or do you want me to go a little easier and come back up to another hard one?
Can I just show us the easy?
Okay, basically the part that makes anything hard is the inside. That's the hardest part, because the other stuff's pretty simple. It's basically rigid movements, right? If you have anything out here, like if I had -2, what is that going to do for me? It's going to drop me down 2, isn't it? And that makes sense. If I had x squared and I had x squared minus 2, boom, I'm down 2. Correct? I mean, that makes sense. Okay? And then, this is your amplitude. So if I have let's just have a -2. I don't know if you guys want negative or positive. Negative it is. Let's switch this, sorry. -2 cosine. We'll make this a 4 now. So y equals, you can always turn a 2 into most numbers. Okay? 2 into 7? That's a simple one. Right there, brother. It's not the prettiest, but it works. Okay, so then let's do pi halves x minus 3 pi halves.
And this is an easier one?
No, this isn't.
So instead of a 2, it's like
Yeah. All right, here we go. That even hurt my ears a little bit. -2 cosine of pi halves x minus 3 pi halves minus 4.
Okay.
Step by step. What movie is that off of? Hi, Bethany. Your little funny eyes always make me, they're really not funny, but just shut up. That's where you're going to say shut up. Okay, if I pull out the pi halves, that is x minus 3. Because remember, all you got to do is distribute it back through and make sure it gets back to what you want to see. Garrett! Garrett the Gingy! Does your straw stay in?
Yeah. I have
Oh, shush. You think you're cool now. Okay, what if this is a plus? What would I do? I'm not going to change it, but what would I do? Shift it to the left. Okay, you guys ready? Where do I tell you that I start with?
With your midline.
Midline. So I'm going to start at -4. 1, 2, 3, 4. Okay, I do a dotted line at my midline. Is everybody with me? Then I use my amplitude. What is my amplitude? Oh my goodness. What is it, James? 2.
Well, we got to flip upside down.
I know, but your amplitude is never negative.
Yes, sir.
Because it's a distance. Can distance be negative? Some people are like, well, you can back up. And I'm like, that's still a distance. You're just going in reverse.
Well, we haven't proved it yet. We could get there. We just haven't proven it through science yet.
Yeah, exactly. Okay. So then we're going to go up 2. So the highest we'll ever be is -2. What's the lowest we'll ever be? -6. Does anybody have a question on how I got those values? Sir?
No, I've got a different question. What should we, so is it still an X, Y line?
It's still an XY axis. This represents Y values. Since we have Y. This represents X, where X is angles in radians.
We're
Okay.
just doing radians.
Huh?
We're just doing radians in the equations now. That's fun.
Well, it's easier to do that because it's more number line basic than degrees is.
So it would be more decimal there.
Mm-hmm.
So this is more exact.
Mm-hmm. Ma'am,
Could you go over how you got -2, -6 again?
just for you. You ready? Okay, so with this being 2, this for -2, that represents my amplitude. Amplitude's definition is the distance away from the midline. So if my midline is at -4, I go up 2 and down. Answer your question? Now, I go to my chart. What are the main 5 that we always start with cosine? 0, pi halves, pi, 3 pi halves, and 2 pi. Now, some of you guys said you couldn't read my handwriting last time. Well, if you can't read the handwriting, listen to the conversation and do the math for yourself. Okay. Now, what we do is this guy first. We don't divide by pi halves. We times by 2 over pi. Because we don't divide by a fraction. We times by its reciprocal. What's 0 times 2 over pi?
Zero.
What's pi halves? And you wonder why my thing's all wobbly. What's pi halves times 2 over pi? 1. Wonder what this increments are going by. So you can just keep going.
What?
They always just keep the same amount. Like whatever this distance is going to be this distance
So
and
it's
this
the
distance.
rates change.
You already know it. Now even if you want to try it, like 3 pi halves times by 2 over pi. Whoop, whoop. 3. You get what I'm saying? There's little tricks. Like even on our last one, what was the increment? Pi fourths. You're consistently adding pi fourths. Right? Does that make sense? Everybody with me on that? Then what is our... Yes, sir. It does cancel out. See, like right here. Okay. Now, what does the -3 do? Oh, I was going to get you, Mr. Textaholic. Then what do? We shift which way? Horizontally to the right. How many? 3. So this is 3, 4, 5, 6, 7. One, 2, 3, 4, 5, 6, 7. Now notice, ladies and gentlemen, notice. Okay? How many cycles are we going to finish by pi halves? I mean by 2 pi. How many cycles are we going to finish by 2 pi? Pi halves.
Pi over 2.
Because remember, B value is the frequency. Notice we're going to basically finish 1.5 cycles, roughly, right? Okay? In a distance of 2 pi, which is basically a distance between 0 to 6 if you think about it, or if we start at 3, we would end at 9, that would be 2 pi. Okay, here we go. Okay, so we start at 3. Now, here's 3, 4, 5, 6, 7, and so forth, right? So it's a cosine. Do we start on its amplitude or its midline? Now, am I going to start on my high amplitude or my low amplitude? Low, because we were originally cosines up, but because it's negative, it's down. So understand the pattern's going to be low, midline high, midline low. Everybody with me on that? So we're going to go low. Midline. High. Who just said wait? I did. Normally, Rochelle, work like this, right? So instead of starting high, we're going to start on our low amplitude. If it wasn't, I'd start instead of here at 3, I'd be at -2 instead. You with me on that? Okay. 5 is high. What about 6? Where's he going to be at? Midline. How about 7? Low. Get a blue here and go. We'll buzz off a little bit. That should do it. And that's just one cycle, right? Okay. Are we okay? What's my amplitude if I asked you? What's my period?
7.
Pi half.
I haven't heard the right answer yet.
3 pi half.
Still haven't heard it.
4.
2 pi divided by.
4. Where do you pull
4
4 out of?
radians.
How long does it take me to start from 3 and get to 7?
Wait. But you gotta count.
What's the distance from 0 to 4?
It is 4.
4. And notice, if when in doubt, take 2 pi, divide it by your b value, which is 2 pi times 2 over pi, and go whoop. 2 times 2 is 4. Notice, right here, ladies and gentlemen, 0 to 4, there's your period. If you look at the last one we did, scrolling down, 0 to pi, what's that distance? Pi. This is still pi, right? It's just shifted. Just the same way on this one, this is still 4, just shifted. Yes, no? Okay? Now, on your homework, it's going to ask you, where does sine equal a half if it's like this? It says something like this. It says like sine of x equals y and a half equals y. What is that basically saying? When does sine of x equal a half? You find your angles that it equals a half. Does that make sense to you? Like, where does sine equal a half? Pi 6 and 5 pi 6. Right? There's 2 places, remember. That's all that's saying on your homework. Sure.
So D tells you
The frequency. So,
it's 2 pi over because you make kind of different things.
well, no. Frequency is just your b value. Now, your period is 2 pi divided by b.
No, that's good.
So understand the difference between frequency and period. Remember, if you know definitions, it helps. Hence why I gave the little idea. A period is one complete cycle. Okay? It tells you how long you can finish it, right? Frequency tells you how many times you can complete a cycle by 2 pi. The difference. Does everybody understand the difference between the two? So in our equation that we just had, give me 1 second. The equation we just had, our b value was pi halves. That is our frequency, meaning we are going to finish pi halves cycles by 2 pi. Or if you think about it, 1.5, right? That's roughly 1.5-ish, 1.57. We're going to finish 1.57 cycles by the time we get to 2 pi if we didn't shift it at all. Make sense? Because that should make sense if you look at this, 0 to 4, that's 1 cycle. Notice by 6, which 2 pi is a little bit past 6, I'm a little bit less than that, right? I'm 1 and a little bit more, if you think about it. If I didn't shift it. Because 2 pi is at 6.28. So at 6, here I can show you. So basically what we just had there, 1, 2, 3, 4, 5, 6 is here. But notice we finish a complete cycle by 4, right? It went dotted line, so basically it goes here, 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 here. Okay, this would be 7, that would be 8. So notice, hopefully I answered some questions here. At 2 pi, which is roughly right there, didn't we get 1.5 cycles done by that time? That's what that means. Okay? Did I answer your question from earlier?
I think so, I didn't even really have words for the question.
Do you feel comfortable on how to graph? Guys, there's only like 3 of them that are the harder parts. So they're actually pretty simple, okay? If they ask for 2 cycles, please make sure you do 2 cycles, okay? All right, textbook time. You're on 4-5. Page number is unknown as of right now. I gotta find it. All right, page 328. That was horrible. Ooh, we should do one of those before we stop. One through 71 odd. No.
It's not every other one.
No. There you go.
Oh, okay, I thought you were gonna have like a whole section.
Okay, really quick, we're going to write an equation from a graph really quick. I forgot to do that. We'll come back to it if you didn't get it. Hold on. That was wrong. That's way wrong. Don't look it up. There we go. Notice sometimes they're not going to give you the one cycle. They might have you continue on and so forth. Like such, right? Does that make sense? So actually there's multiple answers because once again we just talked about the shifting of sine and cosine. Everybody with me on that? What I look for is A, I first say look at 0. Is it starting on an amplitude or a midline? Amplitude, correct? So therefore what do we know? Cosine. Am I starting on a high amplitude or a low amplitude? High, so therefore is it positive or negative? Positive. Is everybody understanding these questions I'm asking myself? What is the midline? On your graph, they're not going to have little dots there. How are you going to tell? The halfway point from the low to the high. So I said, okay, I'm at -4 and I went all the way up to 6. That's a distance of 10, right? Cut that distance in half. I need to go 5 away from my amplitude. So my midline is going to be so far cosine of something plus 1. Now, let's say this is right here at 4 pi fifths. Okay, so we didn't shift left or right. How do I know I didn't shift left or right? Because I'm still on the y-axis up there at my starting point, correct? Great job, Dylan. Okay, what is my amplitude? 5. We already talked about being positive. So the only thing we need to care about is this value right here. So then I come back down and I say, okay, what is my period? How far did it finish in? It finished in 4 pi fifths. What is an equation to find our period?
Oh, I have it.
And then then solve for b. So therefore, you can either crisscross or do traditional math by flipping. And then I say, oh, turn to 2 pi over. B is 5/2. Yes, sir. No, this thing. Oh, shiz. No, it doesn't. This period. Sorry.
So that's just like.
That's what you were trying. Somebody was trying to talk about earlier.
So that's just like the point on the line where it was,
Where you finish your one complete cycle.
and it'll save that on paper.
Or you can see the number of times it finishes by 2 pi. Does that make sense? Like you'll see the number of cycles by 2 pi.
Yeah, and then you just divide it by that.
No, you just count. So like, for example, let's say, hold on, I'm answering this question first.
So that's 2 pi.
So therefore, what's your b value? 1, 3, 3.
So you just write. So would you have to do the 2 pi over 3, or would you just
No.
write?
So therefore, this became 5/2. Yes, Michael.
So when you're writing an equation in a graph, and you're trying to figure out the sine or cosine, you always check to see what zero is.
That's where usually I like it. I'm not going to give you too many shifts when I'm asking you
The
that.
question is, it's shifting horizontally? No. Just assume that's sine or cosine.
Most of the time, that's what I'm going to do. Okay, we good? Go back to the homework. Right there. Already on.